When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to my past HSC exam question videos. In this video we're going to cover this exam question, which comes from the Theory of Acids and Bases chapter. What I'll do in a second, I'll read the actual question. Once I read the question, you get about 5 seconds to pause the video. And once you pause the video, attempt the question, and then press play when you're ready. The question itself says, discuss factors that must be considered when using neutralization reactions to safely minimize damage in chemical spills. And that's worth 4 marks. So when you're ready, pause the video and attempt the question. Welcome back. Alright, so the question itself says discuss factors, so obviously you have to discuss factors that must be considered when using neutralization reactions to safely minimize damage in chemical spills. So you have to talk about factors that help you minimize damage when it comes to neutralization reactions. So overall, you should have 4 factors that would help you minimize any damage, because it's worth 4 marks. So to get full marks, ideally you have 4 factors. So I talked about the idea of having an amphiphotic species as your neutralization agent, because they can both neutralize acids and bases, which means no matter what is happening, you always have something on hand to neutralize it. If it's a base that drops, you got your amphiphotic species. If it's an acid as well, you're fine as well. I also talked about if you don't use an amphiphotic species, you should use a weak acid and a dilute acid, because that means you're going to have less heat being produced, and that means there's less risk of injury. And then what I also talked about is using copious amounts of water, or using large amounts of water to make sure that we can even dilute it a bit more. So that means we have less problems when it comes to heat generation. So large amounts of water being used. And just to throw in a 5th one, I just also said we could use, we should make sure there's no one close by. So no one close by when we do neutralization reactions, because they can be dangerous. So first I talked about the amphiphotic species, so this is this one here. Amphiphotic substances such as sodium hydrogen carbonate, this was the example. That's generally a good one to remember. Are good chemicals to use for neutralization reactions, as they can act as a base and as an acid, and neutralize both acids and bases. They also come in powder form, which makes them easy to clean up post-neutralization. So I guess this is another safety thing. If you use powdered, that means they're quite easy to clean up. Less chance of spilling something on your actual hands or whatever else. But I could have also mentioned that because you can use them as acids and bases, that means you're going to be more safe in a lab, because you can just use one chemical to neutralize whatever happens. Whatever you spill, you've got that one chemical on hand. But this is just generally is enough, because we also mentioned the powder form. Generally that's enough to get you a mark. So going for the first one, the amphiphotic one. Then I said if sodium hydrogen carbonate is not used, then a weak and dilute acid, so actually it's just mentioned 2 in 1, weak and dilute acid or base should be used instead. This makes sure that the resulting heat produced is minimized and reduces the risk of injury. If, for example, in your answer you talked about that neutralization reactions produce heat, and then that could cause a problem, if that's what you mentioned initially, that's also good. That's a good way to start. You can mention neutralization reactions are actually exothermic and thereby produce heat when happening. So, but in this case we talked about using weak and dilute acids to minimize the risk of injury. And now I'm going to talk about having no people close by. Neutralization reactions should be performed away from students/people, especially if large amounts of concentrated acids or bases are involved. These are often when it comes to massive chemical spills. In your lab you probably have smaller ones, but still generally have as few people close by as possible, as this further decreases the risk of injury, especially of the heat-related injuries. So that's a mark as well. And then we get one more mark. Again, this will be 5 marks because I've just mentioned 5 points. But I mentioned the next one with the additional water. Additional water can also be used to further dilute the concentrations of acids and bases and reduce the risk of excess heat production causing injury. So the more dilute it is, the less problems it will cause. So hopefully that was useful, but that would be your 4 to 5 quick points which means you would have gotten your full marks for this question. And where this question come from? It came from this dot point. Analyze information from secondary sources to assess the use of neutralization reactions as a safety measure or to minimize damage in accidents or chemical spills. So it says safely minimize damage in chemical spills. So they chose this part of the actual question. But I hope that was useful.
Thank you for watching.